Welcome, everyone. So we would like to start today's session, our second session of Journal Club. So thank you, everyone, for joining. Today, our presenter is Dr. Anisuzzaman. He graduated from Asunnola University, and he did his PhD in Milwaukee University, Wisconsin Milwaukee University. He is an outstanding engineer, though he is in Mayo Clinic. It's like a rare combination, but soon when he will present his paper, you'll clearly understand that how engineering field or computer science will help us a lot. So I'd like to invite Dr. Anisuzzaman Razun to present his journal. Thank you.
Thank you, Mayor. I'll just share my screen now. Thank you everyone for joining. Today I will present my original paper on multimodal wound classification using wound image and location using deep neural network. I am DM Anisuzzaman. So before going into the whole problem, here is the context. So there are mainly 4 types of wound images or wound classes, which are most profound classes in the wound society. They are diabetic foot ulcer, pressure ulcer, venous leg ulcer, and surgical wound. So our target is to classify these 4 wounds from their location and their images. So this is the overview of the whole system. We'll give a wound image and the system and its corresponding location in the system. And the system will tell us, the artificial intelligence or the deep learning model will tell us what type of wound is it. So there are a lot of work on wound image classification, like you will just give this wound image in the classifier and it will say like what type of wound is it. But to the best of our knowledge, there is no automated wound classification work based on wound location only. And also to the best of our knowledge, this is the first work that incorporate both wound image and its location to develop a multimodal wound classifier. So to perform this experiment, we actually collected our data from AJ's Wound and Vascular Center located in Milwaukee, Wisconsin. And there are 4 types of wound in the dataset. They are venous leg ulcer, diabetic, and pressure and surgical wound ulcers. So these images are taken like without any specific environment. Just they are taken in freehand using iPad Pro and a Canon digital camera. Second, there is a Meditech data set, which is publicly available wound data set, which contains all free stock wound images, from where we randomly collected 358 images, including diabetic, pressure, and arterial and venous ulcer. This data set doesn't contain any surgical wound images, and they don't differentiate between arterial and venous leg ulcer. So these 2 are a single class in this data set. And finally, we create a bigger data set to see the effect of deep learning models with big increasing data set, which contains 1088 wound images by combining both AJ's and Meditech data set. So for the body map, so for the location tagging, we developed a body map which contains 484 total parts. We use a software called Paint Code, and we follow the original anatomy mapper developed by MIT. And we actually focus on some specific part of the body where the wound is most likely to appear, and we assign a unique number to each body part. So I'll just show you the body part. This is the body part. You can see this is the full body map. So this is the front view, the back view, the view from left side and view from right side. And as I told you earlier, we have some special focus area, which is the hand, legs, and buttock area. So in this area, the 4 type of wound I talked about is most likely to appear. That's why these body maps are more detailed. And though you are seeing a number for this in this body map, they all have a specific name. So these are the names, like left dorsal wrist has a reference number 152. And all those locations, 484 locations, has a specific reference number. And in our deep learning model, we actually use this reference number. So for the dataset processing, we have actually 3 steps. The first one is region of interest or ROI cropping. The second one is location labeling, and the final one is data augmentation. For the ROI cropping, in some cases, actually, except one case, in all the previous classification or segmentation work, all have done it manually. But we have developed a deep learning model to do this location cropping using artificial intelligence or deep learning models. So I am actually going through another paper. So this paper actually published in IEEE Access already, and the multimodal network that I am talking about is accepted in Nature scientific report, but it's not published yet. Hopefully it will be published within next few days. In the wound ROI cropping, we just pass a wound image, and the wound localizer will localize this wound. Like from this whole wound image, we just take this part of the wound. So there are significant importance of this step, because by localizing the wound, you are actually anonymizing the wound image. That's why that's how actually we made this localized wound dataset publicly available. But we cannot make this whole image dataset publicly available, because you can like identify a patient using like some identifier. Let's say patient have a tattoo, or some has some like tagging or name written or everything. So by localizing the image, you just anonymize it, and also you reduce the work of deep learning model by a lot. Let's say this image is like 1080 by 1080p. When you localize the wound, it's only like 200 by 200 pixel image. So the all computation in the CNN model and everything reduced a lot when you do the convolution. So I'm just going through very quickly for this localization part. For this problem, we also collected dataset from AJ's Wound Center and Meditech Data Set. We augment by using some rotation and flipping, and we created the bigger dataset. So for the location labeling, we used a MIT licensed free graphical annotator tool called Label Image. So you can draw a box around the wound, and it will give you the center of the box or rectangle box, and like XY position and the height and weight of the box. So by using this information, you can just easily localize the wound. So we manually localize our training set, and from our testing set, we just test it like how good it is doing. So we use 2 models. One is YOLO V3 and another is SSD. So I will not go very deep onto this model, because most of my audience in here are from medical part. So for the feature extraction, the YOLO model actually used the darknet 53 layer. So by feature extraction, I mean for this wound image, you just extract its color or texture or age or shape, which gives you like, okay, this is wound, and the deep learning model will draw a bounding box over it. So the feature model is done, feature extraction is done using darknet 53 layer, and there is some upsampling layer, because when you do convolution, they just reduce in size, and you just upsample it, and from the upsample layer, you just detect the bounding boxes, which is done by yellow layers. So we trained another model called SSD, or single shot multi-box detector. Sorry, single shot multi-box detector, where the VGG16 and 5 auxiliary convolution layer is used for feature extraction, and only 1 layer is used for object detection. So I'll just go directly into the result because as I said, this is a sub paper of this whole paper. So for the ages wound database, we got a MAP value, which is called mean average precision, which is the average of the precision for a specific recall value. So the MAP value is the metric which is most commonly used for localization task, like any kind of localization. If you see like car localization or any other word, the MAP value is the one that people report for their model's performance. So for the small dataset, we got a 0.939 MAP value, which is pretty good with considering the small dataset. And the base model is YOLO V3, where the SSD gives us only 0.864 MAP value. And when we did this performance, YOLO V3 is the latest one, like it's on 2020. Now I believe there is YOLO V5 model, I think, which will perform better maybe. So there is a bigger dataset we built using the Edge and Meditech data set, and we can see that the MAP value increased from 0.939 to 0.973. And this model, this YOLO V3 trained on this bigger dataset, is actually used for our location tagging. You can see this is our dataset for the multimodal classification, and this is the data processing part. So we pass the images through the ROI detector that I just described, like YOLO V3 model or trained YOLO V3 model, and it just gives us this ROI. It automatically crops this part from these images. And a wound specialist from the wound Edge's dataset, Edge's center, actually localize the wound or pinpoint a number for each ROIs. So like this ROI has a number 229 tagged with it. And after location tagging, we just augment it using rotation, flipping, and some blurring. Sorry, not blurring, only rotation and flipping. So you can see like this is an example for diabetic foot ulcer data preparation. This is an example of pressure ulcer data preparation. This is an example of surgical wound data preparation, and this is an example of venous ulcer data preparation. So for multiple wounds in a single image, the model also gives us two ROIs, and the physician from the wound center actually tag these locations, and we augment these ROIs using our augmentation methods. So after, so this is the dataset statistics. We use 60% of our dataset for training and 15% on validation and 25% for testing. The validation and test dataset doesn't go through the augmentation, only the training dataset go through augmentation. Also, we introduced two new classes. One is normal skin and another one is background. So from this image, if I just draw a rectangle box here, we just called it normal skin. And if I just draw a box in this bed sheet, it's called background. The reason we did this because we want to compare our result with previous works, and there are some work that actually uses these two classes. As background, ROIs doesn't belong to any body part, so we just give or tag the location number as -1. So this is the statistics of the whole dataset after augmentation. We can see from the Edge's dataset, we have 4,176 ROIs after augmentation, and for testing, we have 234 ROIs. From the Meditech dataset, we have 1,608 training and validation and 90 for testing. And for the bigger dataset, we have 5,784 for training and validation and 324 for testing. So the model I used here is called Wound Multimodality Classifier, or WMC network, which actually takes both wound image classifier, which is a separate network, and a wound location classifier, which is another network, which are concatenated and then pass through some more dense layer. So I will really appreciate some question if you have some like something to say, because I know this is not your area. So please feel free to ask any question in between. So in general, we actually use sequential API to develop deep learning models, but this model is built with Keras functional API because we need two different modality of data. Not the one data is coming from image and another data is coming from location, which is actually just a number. So to feed this number into the network, we just convert it to one hot representation. So in one hot, that means that the total number of locations, so there are 484 locations, only one location will be 1 and all the other will be 0. So there will be an array where you will just assign 1 to the location that the physician tagged and all the other will be 0. So I'll just show you
I have a question.
Sure.
Yeah, so can you explain a little bit normal term, what's the use of this network? Means wound image classifier network and wound modality classifier network. What does it mean?
Okay, so I think it will be more easy to show in visualization. So yes, so this is our wound image classifier, the top one. So what it does is that it only classifies the wound images. So if you just give a image in this classifier, it will tell you, okay, what features does it process, or it can also classify the wound image to a specific class, which has a lot of previous work that I told you before, that they are made with convolutional layer and dense layer, and they just take wound images. And the purpose of wound location classifier is to classify the wound locations. So they are just built with either LSTM networks or layers or the dense layers. So if you just pass the location data over through it, it can tell you like it can guess what type, like if you just give a location, let's say if you give 9 and that belongs to some location, let's say head. So it will gaze on the given data that diabetic pressure ulcer or diabetic foot ulcer or pressure ulcer or any other type of ulcer is most likely to appear on head. So it will give you that, okay, if you give 9, it is the output class is pressure ulcer, something like that. So what the whole model is do is that we pass the image through the classifier network and pass the location through the location classifier, and then we concatenate the feature extracted from these two classifier, and then pass it through some more dense layer, which and then pass it to the output layer, which will give us this one of the 6 classes. Like it will just combine the image features and the location features both together. Like if you give the model a image and its corresponding location, like here you give 9 and here you give the image of head, then the classifier will be more certain that, okay, we have this information from the location image and this information from the location. So this total combination is most likely to be pressure ulcer, something like that. So
yeah, thank you.
Yeah,
it's
thank you.
A little bit clear.
Yeah. So for the experimental setup, we use the Python programming language and Keras deep learning framework. We have a GeForce RTX 2080 Ti GPU platform, which I believe is 12 GB of GPU memory. We run each model for 250 epochs because we have very small data set considering the deep learning models. And these are the batch size, learning rate, and Adam optimizer is used. I will not go into details like how this deep learning model will work. So there are 2 callbacks used, like this 250 epoch will give you 250 models. So you want to save the best model. And to save the best model, you actually focus on the validation data. So there is 3 data: training data set, validation data set, and test data set. So the model that performs based on your validation data, you saved it for your test data because you are not showing the level of test data in the model. So when you feed the test data on the best model, it will just guess, okay, this is the result. Like this image and this location is most probably pressure ulcer, this image and this location most probably diabetic foot ulcer, and etc. And as we have already annotated result saved in our cases, like the physician already did it. So we just match the result predicted from the model and the result done by the annotator or the physician and give a score, which is called accuracy score. And in some binary cases, we also show the precision recall F1 score and other matrices. So as you can see, there are, sorry, I didn't explain the whole network here before. So we use 4 transfer learning model, which are called VGG16, VGG19, ResNet 50, Inception V3. So if you are familiar with the deep learning domain, these 4 are really popular network for image classification, not only wound classification, any type of image classification. Like these all are actually tested on a bigger data set, which contains 1,000 classes actually, like cat, dog, car, etc. images. And they are very popular. That's why we use these CNN models. And there is AlexNet, which I just show it separately because AlexNet doesn't have a Keras module for transfer learning. So this AlexNet is learned from scratch. Like again, transfer learning means you have a saved model, or you have a model that is trained on a different bigger data set that I called already, that it is trained on millions of data, but they are from different images like cat, dog, etc. So why do you do transfer learning? Because this model already knows some basic features like age, circle, some color information, and etc. So it can easily do the same feature extraction from your wound images, like wound age or wound color or wound texture, etc. So as you can see, there are 5 image classifiers and 2 location classifier. And if we combine them for the multimodality, there are a lot of classifiers. So we have a lot of experiments like designed here, but we don't want to, or we don't have the capacity. By capacity, I mean like both time and memory cost. We don't have that for training all those models for all experiments. That's why we took the best result on a specific experiment, which we believe is the most challenging one, which is the classification between 4 wound classes. They are diabetic, pressure, surgical, and venous. Why they are most challenging? Because it is like, from our general sense, we can say like diabetic versus normal skin is more easy to classify by, like even a non-physician can tell, okay, this is wound image, this is a normal skin, or background versus diabetic. So when we do the classification between wound and wound, it is the most challenging one. And you can see the combination of these two actually giving us like 78% accuracy, and this combination of two giving us 79% accuracy. So this is the highest result we have till now for this 4-class classification. So if we just give in our dataset like 230 images, almost 80% of time the model is correct. They correctly classified the whole combination, like the body, the image and its corresponding location. So on the experiment on AJ's dataset, we did a 6-class classification. That is the classification between all the 6 classes. So the main reason for doing this multimodal classification is to show that combining 2 different features from 2 different sources will actually improve the result, which it did. You can see that from the location data, we only get a 60% accuracy. From the image data, we got only 75% accuracy. From the multimodality, we get 82% accuracy. So the accuracy improved at almost 5% using the model, both modality or the concatenation from these 2 models. So we performed another 5-class classification, and there are like different 5-class classification. So as you can see, there are 4 5-class classification, 1 6-class classification, and in all these cases, the location and the multimodality gives us the highest result. So then we did 6 3-class classification. Sorry, okay. Is there a way to hide this? Yes. Okay, so there are 6 4-class classification, and you can see in all those cases, the multimodality performed base, and also for 3 wound class classification. So by wound class classification, I mean there is no background or normal screen present on these classifications, and they are most challenging one. And for this 3-class classification, we have this accuracy here. And we did 10 binary classifications. And as you can see, as I told you before, that normal versus diabetic pressure ulcer is really easy to classify, and we actually get 100% accuracy. But interestingly, only if you give image, it's not giving you 100% accuracy. It's like 98.5 or 98.6% accuracy. And if you only give location, which is giving you highest of 78% accuracy. But if you combine both, it is giving you 100% accuracy. So there are some other matrices for those binary classifications. And we perform only one experiment on the Meditech data set. And here also you see the combination of image and location, all the multimodality give us the highest result. Also, we perform a 6-class classification on the bigger data set and see the same output, and a 4 wound class classification on the bigger data set and see the same output here. And we also perform the 10 binary classification, and we observe the same type of output. So from the performance analysis, this is the most important finding, that in all the experiment, the wound multimodal classifier outperforms the single modality classifiers, that is wound image classifier or wound location classifier. And we found that diabetic versus pressure versus surgical, specifically pressure versus surgical, is the most challenging one to be classified by our model. And surgical versus venous is the most easiest task to be performed by our model. So I don't know like why they're most easier or why they're most difficult, but from our physician, we get the feedback that they are actually true in medical senses. We see the same type of result on the AJGMT dataset or the bigger dataset. And there are some location overlapping issue. As I told you before, this is very small dataset comparing our, considering the deep learning models. Like for this number 83, you can see like back left ankle, it appears 6 times in diabetic pressure ulcer and also 6 times in, diabetic foot ulcer and 6 times in pressure ulcer and 4 times in venous ulcer. So it is very difficult for a model or deep learning model to distinguish between these 3 classes when you have like similar type of example in both classes. So in near future, if we have more data set, we can improve the overall performance of the whole model. And we compared our work with all the previous work, and for these 3 work, we actually outperformed them by very good margin. And this work performed by Behruz Rostami, who is actually working as a senior data scientist at Mayo Clinic right now, who is my former lab mate. And this paper also, I am an author here. So we just perform these classifications using wound image, and using the multimodality, I show that we outperforms all the previous results. So here you can see some results are not outperformed, but later we actually outperformed all of them. I cannot share it right now because the paper is not published, the final version. Hopefully it will be published very soon. So I just showed it from my archive paper that I shared. So in summary, we developed a novel wound multimodal classification. And this is the first multimodal network for wound classification specifically. We also developed a body map that not only is useful for this experiment only, but it is also useful in wound clinics. Like when we collected data from wound clinic, we saw that there are some inconsistency between body map tagging. Like one nurse tagged the, Here, so one nurse tagged a location for a patient, let's say left dorsal wrist. The next visit, she just wrote left DW. And the next visit, she just left LDW. So it's really inconsistent and really hard to, like, if you try NLP models on the free text, it is really hard to tag the locations from the free text. So what we did, actually, we use these locations to develop a mobile app where you can actually just select a location. Sorry, I'm just drawing around. So here you can just touch a location. Let's say the nurse will see the image and he or she will see that the wound is most likely to appear in 153 region. So he just will touch this 153 and it will be tagged automatically with the specific location name. So the body map is really useful and actually currently used in AJ Wound and Vascular Center. And yes, so our work also outperforms all the previous works. Yeah, and we have performed a lot of classification experiments that was not performed in this wound domain before using deep learning models. So thank you for listening to me. I will really appreciate your question and advice.
Yeah, thank you very much, Rajan. So I have some question in chat box. Anyone wants to ask any question, just unmute himself or herself and then ask question. Rajan, let's welcome everyone. So,
if I may ask, Moin Bhai.
Sure.
First of all, thank you for organizing this event. It's very nice. And thanks to Rajan. Very intriguing work.
Thank you.
Very nice. Couple of questions.
Sure.
So the results you have, right, those are based on the training data or the final test data sets?
Test data set.
Right. So the accuracy of 100% or above 90% is very, very good, very interesting.
Yes. I mean, as I tell you, like, these are really easy to say. Like, you can just see a normal skin and a diabetic pressure ulcer, or
right.
Like, it's really easy task for any classifier. Like, if you see this skin, you will just automatically say it's a normal skin, and if you see this skin, you can just automatically say, okay, it's not a normal skin or pressure ulcer or something like that.
Right. Exactly. So the question I had. Did you also look at any other performance metrics other than accuracy? But as you know, the accuracy might have some problems with the class imbalance. I forgot if you showed the distribution of different groups.
Yes, I have some class imbalance, but
so the problem with the accuracy sometimes is, like, you know, if you have a class imbalance, let's say 80% and 20%, any random model, just say everybody is, like, let's say, you know, class A. So you're going to get an accuracy of 80%.
Yes,
so I was wondering if you have any other.
Yeah, so for the binary classifications, I showed the precision recall and F1 score. But for the multi-class classification, I didn't show this because they are more complicated to show. Like, you have to show class-wise precision recall and F1 score. So if you just show six precision for 6 classes and 6 recall for 6 classes, it will be much harder to anticipate.
Right. And the question I had, so with the data set splitting, right?
Yes.
So you split it once, and that's the results you got. I'm just wondering what happens. You do another round of, you know, splitting. Let's say, because
yes. So yeah, and that's why I am smiling.
It's a random nature, right? Do you?
Yeah, I know that. So that's the same question I got from the reviewer from the Nature, and I actually did a cross validation on 5-fold cross validation on the whole data set, and I spend my.
Even if you do the cross validation, you're doing on your training data. Let's say if I
no, it's the training and validation data combined. Actually, no, sorry, it's the whole data set. There is no test data. So in the 5-fold cross validation, you just take the whole data set So if you say 5-fold, so there are 80% for training and 20% for testing. There is actually no validation, though it's called 5-fold validation, but there is no validation. They are just testing. So on the testing result, you get 5 accuracy for 5 different folds, and you got a average accuracy. And interestingly, in the 5-fold cause validation, also the multimodality network outperforms all the other networks.
Yeah, within the whole data set, that's interesting, because with the whole data set, if you do a cross validation, there might be a chance. I don't know. There might be a chance of data leakage, because
yes,
you're doing your
there are some
randomly, so there's a chance, even if you're doing the whole data set. But yeah,
I can show you. I'm not sure if I am able to show it because it's not published yet.
Every time I see my question arises, how reproducible is the result?
Yes, I see. And yeah, as I also told in my published one, that this data set is really small for deep learning models. Like you can, sorry, I'm just losing my slide numbers. Here, you can see there are only 234 ROIs. They are not images. So I have the results here. So I have only 730 wound images, which is really small for deep learning models. So currently the project I'm working on, Mayo, they have more than millions of patients. So I have to subsample like to 10,000 or 20,000 for our models, which is more reliable result is produced here. So it is my PhD work, and this wound age wound vascular central clinic is really small clinic where we cannot collect more than this number of images. And actually the whole project take around 2 years, where 1 year and 5 months on 1 year and 6 months goes for only data preparation. So you can see like the scarcity of data for the big data, big models, deep learning models. Yeah.
But thank you so much. Very interesting work.
Yeah, thank you so much. They are really interesting question, and I completely agree with you, because accuracy for my current project I'm doing in Mayo, I am actually not showing any accuracy. I am just showing the AUC or ROC curve, that is the curve between sensitivity and 1- specificity crossing, which is more reliable result for imbalanced data.
Right. I mean, AUC might be a better choice than accuracy, but you might also want to, show the area under precision recall curve, AUPRC, or maybe kappa, some other, that covers class imbalance as well. But thank you.
Yeah, thank you for your question. So I have some question in chat. There is only one. So to answer the question from Alpona is that how augmentation is helping if there is only one wound. So the reason we did the augmentation, so there are actually 2 reasons for you do augmentation. One is for model variability, and another is for increasing the data. So I just do it for increasing my data. So as you can see, there are 730 images, which later give us like around 1,000 or 1,000, 1,200, sorry. Yes, 1,200 ROIs, but after augmentation, we got around 4,176 images. So yes, I believe that they don't help you that much, but in some cases, they actually help you. Like instead of just passing this original ROI, you are just passing some other places, and like it's just telling you that we are training the model to see the wound from a different angle or different perspective. That's all. Hope I answered your question.
Thank you very much.
Anyone have any questions?
What is the chat?
Does anyone has any more questions?
I'm sorry, I just have one more question. Those
Yeah,
it will
sure.
be, yeah, though it will be a silly question, but just in my mind, can you? Is it possible to add the duration in your, like in some next modeling or something?
Yes,
For
thank
example,
you
how long
for
this?
this question. Actually, the main purpose of doing this multimodality is to create a prediction model, like in own domain or own classification or anything like in the own business, I would say. What is the final AI model you want? You want a model that can predict whether your wound is likely to be healed after some specific weeks or specific duration. So that is our main target to do. So this multimodality is actually the core model that gives the whole project or takes the whole project one step ahead. So in this multimodality, like here you see, I am just using the image and the location. You can use anything in this model, like the patient age, patient sex, patient BMI, and like anything like patient's blood pressure, everything. And by combining all those things and all those information, the model will predict, okay, this is your current state of the wound, and you are most likely to be healed within 8 weeks with this percent of probability. Like you have a 90% chance the wound will heal with proper treatment within 4 weeks, something like that. So this will actually help a lot in the wound domain. So sadly, I just leave this project, and my lab mates may be continuing this next steps, hopefully. And yes, thank you for this question. This is really interesting. And we have some actually prognosis work done from the electronic health record or EHR data, where we collected like patient age, sex, height, weight, BMI, blood pressure, and some other tissue samplings like CELAS or like ASCAR or something like that. And we are predicting like how most probable the wound will be healed within next few times or few period. And that paper is also published in a elsewhere publication. You can just look for it. It's a synthetic data model for wound prognosis.